Okay, here we are with example 2, and Caleb's doing an experiment, and I'm just going to write a few things that were given in the question. So we've got let me find my better pen. We've got a resistor, which is 9 ohms. We've got a supply voltage of 12 volts. We've got a magnetic field strength of 1.60 Tesla. And that will keep us busy for now. So in part A, we have to work out the direction of the magnetic force by first finding the current and the magnetic field. So the current is going to be coming out of positive and going into negative, so it's going to come this way through the piece of aluminium foil. So that's current. Remember, that's the direction that your thumb is going to point. Magnetic field always comes out of north, so it's going to come across this way. So that's B, and that's the direction that your fingers point. Now, if you actually do that with your fingers, you will see that your palm is pointing up to the ceiling, and so the force experienced, dear, that's not supposed to happen. Let's go back to our pen. Oh dear. Force is up to the ceiling, and that's where your palm will point. So that's the answer to A. And all of those things are at 90 degrees to each other. So the force is up. Part B, explain why the foil experiences a force in the direction that you have stated. So each particle inside the foil experiences a force which is perpendicular to or at 90 degrees to the current and magnetic field. So because each particle experiences a force, experiences this force, the foil also is forced upwards. Okay, and it always has to be at 90 degrees to the current and the magnetic field. In C, we're asked to calculate the size of this force, so we use our Bill equation. And you'll notice that we don't have a current, but what we do have is a supply voltage and a resistance. Oh, dear, going too fast. Okay, so the resistance is 9, so our current becomes 1.33 amps. And we're given a magnetic field strength of 1.60, a current of 1.33. Now, here is where you have to be really careful, because the aluminium foil is 10 centimetres long, but the poles of the magnet are only 8 centimetres long. So this is the one that we use because that's the amount of foil which is inside the magnetic field. So we need to, and we also need to use SI units. So only 8 centimetres of foil is inside the magnetic field, and 8 centimetres is 0.08 metres. So that's where that comes from. I'll just that's a little aside there. When you calculate that, you get 0.17 newtons for the force. That's for part C. And then part D, I can't quite remember the question. If the length of the aluminium foil doubles, explain what effect this would have on the size of the magnetic field. Now, it's only, so go back to this bit here, it's only the foil inside B, it's really important, which experiences a force. Now that is only the 8 centimetres which is inside the field. So if the foil doubled in length to 20 centimetres, it would have no effect on the force. Okay, because it's only the foil which is inside the magnetic field that experiences the force. Thank you.